Hello students. So this is the new lesson rational numbers. I am your Shruti teacher. See here in the number system we have studied about from the natural number we have studied, isn't it? From the natural number, after whole number and integers, again fractions, isn't it? So that all kind of different types of numbers we have studied in a number system. In the same way the rational number also the type of numbers. See, natural numbers are there in whole numbers are there in an integers all are not there in a fractions, but this integer and fractions together are called as a rational numbers, even whole numbers. Why I have not taken the whole numbers? Because in integer 0 is there. So here, so rational numbers, it indicates how it is fractions. See, fractions we can write as a 2 by 3 is a fraction, isn't it? Okay, then if 2 is a fraction or not? Yes, we can write 2 as a 2 by 1. In the same way, see, in the fractions only positive numbers we are going to write in the p by q form. Okay, numerator and denominator form we will write in the fractions. So those are the practical way we can tell. So rational numbers indicates the integers. That means even the negative numbers also called as a rational. Rational numbers are nothing but a number that can be expressed in the form of p by q, where p and q are the integers. Maybe negative, maybe positive, or maybe 0. But there is a condition for the 0 where and q is not equal to 0. That means denominator it should not be 0 always, because it doesn't have a meaning. So are called as rational number, is called a rational number. So it is called. Okay, then can you tell me the examples? Is minus 2 by 7, 3 by 8. Even 3 is also rational number, because 3 we can write as a 3 by 1. Okay, 1 is also integer or a whole numbers, isn't it? Then minus 5 is also a rational number. Then all integers, fractions together are also a rational numbers. Keep it in mind. So in a rational numbers, positive rational numbers and negative rational numbers are there. See, positive rational numbers are only positive fractions. Example as a fraction you can tell. All fractions we can tell as a positive rational numbers. If it has a numerator or a denominator negatives, then those are negative rational numbers. So minus 4 we can write as a minus 4 by 1. So denominator is 1, isn't it? So that all we can remember here. Why the denominator should not be 0? Because 0 by anything. So 0 by any number can be write as a 0. But any number divided by 0, it doesn't have a meaning, means not defined it is. If you go for the college, if you go for the higher study after the SSLC, we can take it as a infinite. But for the time being, you can understand anything divided by 0 is not defined. That's why the denominator should not be a 0. So it should be other than 0. So anything 0 divided by anything is 0. Then equivalent rational numbers. See here, equivalent rational number is nothing but you have studied the equivalent fractions, isn't it? So equivalent fractions, what you have did, if the 2 by 3 is a fraction, if you want to find the equivalent fractions, what you will do, you are going to multiply the numerator and denominator with the same number, and you will find the equivalent fraction. Okay, in the same way here you can do it, isn't it? We can do it for the rational numbers. Same, nothing happens here in the comparing all fractions properties, processes, addition, subtraction, and multiplication and division of all the fraction operations applied to the rational number. Keep it in mind. Only the thing is, in this negative numbers will come, in the fraction negative numbers will not come. if the negative numbers comes, you know the method. Okay, if both are minus, you're going to add. If both are plus, you're going to add. If you have one is a negative, one is positive, you are going to subtract in a bigger number and keeping the bigger numeral sign. In the same way here also, equivalent rational numbers, if finding the equivalent rational numbers, minus 2 by 7, so directly multiply 2 by 2 here, so minus. In the same way you can find the equivalent rational numbers, so minus 2 by 7 into 3 by 3 minus 6 by 21, because we can multiply the numerator to numerator, denominator to denominator, as if we have done in the fractions. Same thing. So if you multiply 4 by 4 minus 8 by 28, again 5 by 5, we can get the minus 10 by 35. Okay, so how we can conclude? Minus 4 by 14, minus 6 by 21, minus 8 by 28 and minus 10 by 35 are the equivalent rational numbers of minus 2 by 7. As if you have done in the fraction, you can apply. Only negatives may come in the examples, that's all. Now rational numbers on a number line. See, we have studied about the fractions also on the number line. What we have did, if the minus or a 2 by 5 if it is there, means we will do the between 0 to 1, 1 to 2. What you will do, total number of parts are the denominators, 1 2 3 4, fifth one is 1. So at that time second one is a 2 by 5, we will locate it. So it is from the right to left to right, because 2 by 5 is a positive fraction. That's why if it is a negative, what we will do, we will go for the right to left here. In the same way, I have taken example minus 5 by 8. So denominator containing 8 means we have to make it as a 0 to 1, 1 to 2. Total number of parts are 8. So 1 2 3 4 5 6 7 8. So 8 parts are there. In that again 1 2 3 4 5 6 7 8. Okay, in the same way, but here minus 5 is there. Minus 5 is there. See, positive means we can, from the 0 we can go for the right side. If it is a minus, we can go for the right side, left side. Okay, in the same way we can count it as a 0 from here to here as minus 5. 1 2 3 4 5. So fifth one is a minus 5 by 8. If it is a 5 by 8, what will do, here from here to here we have to do 1 2 3 4 5. So it is a 5 by 8. Keep it in mind. So minus is here. So minus, if it is there, means go for the from 0, and plus is there, means count it like this. Okay, I hope you understand the rational numbers on number line. So we can go for the exercises together. We can go for solution of the rational numbers. So don't forget the methods of rational fractions here. So all are applicable in the rational number. That's why I'm going very fast here, you can understand. See, list 5 rational numbers between. See here, this is also very important. How we can write, list 5 rational numbers between minus 1 to minus 1 to 0, means here if it is a minus 1, if it is think it is a 0, here it is 1. So here 5 rational numbers we have to write it. So if you need 5, so multiply numerator and denominator to the both the numbers by 6 by 6. For both the numbers 6 by 6. So equivalent fraction you can come to know. Okay, so at that time what it becomes, answer becomes minus 6 by 6 minus 0 by 6. So at that time what it becomes, if it is a minus 1 by 6, 0 by 6. Okay, at that time what it becomes, here 0 after, like this, answer, sorry, this is a minus 6 by 6. So here if you are going from the 0 to left side, minus 1 by 6, minus 2 by 6, minus 3 by 6, minus 4 by 6, minus 5 by 6, after minus 6 by 6, because these are minus, because that's why we are going from the right to left from the 0. Okay, see now, 1 2 3 4 5. Is it not a 5 rational numbers between minus 1 and 0, isn't it? So this is how we have to do. So in a simple way, let us write the minus 0 and the minus 1 and 0 as a rational numbers with the denominator 6, because 5 we need means we have to multiply with the 6. If you need 4, multiply the numerator and denominator by 5 and 5 by 5. Okay, when it is only, if it is 4 5 by 5, if it is 5 6 by 6, when it is only, because when the continue numbers are there, see 0 after minus only 1 is there. Okay, again if it is a minus 2 to minus 1 means direct numbers are there, means at that time only we have to take the 1 extra to multiply. If it is extra numbers, we can go for the examples, I'll show below. So here minus 1 is nothing but minus 6 by 6. So 0 is nothing but 60 by 6. So these are the numbers we can write it. How I showed now in the number line. Now here also see minus 2 and minus 1. Just multiply the minus 2 for the 6 by 6. You'll get a minus 12 by 6. Then here for minus 1 6 by 6, you'll get a minus 6 by 6. So minus 6 after, what are the numbers? Minus 7 by 7, reverse process, bigger number. Minus 11 by 6, minus 10 by 6, minus 9 by 6, minus 8 by 6, minus 7 by 6. So directly minus 6 by 6. So if these are the 5 rational numbers, you may simplify also these are, because 6 and 10 have a common factor 2, so 2 3s are 2 5s are, so it may become a minus 5 by 6. So it is a 3 2s are 3 3s are, so minus 3 by 2. So 2 3s are 2 4s are, like that also you may write here. So in a simplest form they have written like this. Okay, so these are the 5 rational numbers between minus 2 and minus 1. Then minus 4 by 5 and minus 2 by 3. See here, very important here, because these are not having a common denominator. How we can write? But we need the same denominator, isn't it? So what we have to do is, so take the LCM. So take the LCM of the denominator. So LCM of a denominator is what? 5 and 3 is 15, isn't it? Is it not? So we have to make it as a same denominator, means we know the method when it becomes same denominator while taking the denominator LCM in the fraction. Have you studied or not? Remember or not? So if this is the case, what we have to do is, so for minus 4 by 5, multiply 15 by 15. Okay, then for the answer comes is minus 5 ones are 5 3s are. You can cancel. Only we need the 15 in the denominator. 4 3s are 12. So 12 by 15 you may write, or minus 2 by 3 into 15 into 15. So 3 ones are 3 5s are. So minus 10 by 15. So these are the required fractions also you may write, or directly here they have written the 36 only without cancellation, because we need the numbers, no? That's why. That means minus 4 by 5 into 15 by 15 is equal to 45. If you taken the direct LCM only, what it becomes? Minus 12 by uh, minus 12 by 15 and minus 10 by 15 comes. Okay, for this one, if you are taken directly, what it becomes here, see, minus 10 after minus 11 by 15, so directly minus 11 12 only one rational numbers we got. So this is not the case, we cannot take. So what I'll do, if you are taken the 2 multiplication for both, what happens, see, so minus 24 by 30, so minus 20 by 30. Okay, again see here how many rational numbers you can get. So minus 21, minus 22, minus 23, only 3 we can get, but we need 5, no? So what we have to do, again we have to multiply by 3 by 3, better 3 by 3 we can get. So what we have to do is minus 4 by 5 into what we can multiply, 9 by 9 directly I'll take for example. So both the numbers, then so 9 5s are how much, denominator 45, so it is minus 36. So we need the 45 only there. So for minus 2 by 3, what I'll multiply to get the denominator as a 45, so 15 I should multiply. Okay, then at that time 15, so minus 30 comes. Now 31, 32, 33, 34, 35, see 5 we can get. So this is how we can check to get the numbers. Okay, so here are the numbers, we can write the equivalent fractions here, equivalent rational numbers. So if you simplify, you'll get these by cancellation. Okay, then go for the minus 1 by 2, 2 by 3. So now here also the denominators are different, so we have to find the equivalent fractions of having a denominator same. So denominator same means which number we have to select to take a denominator same. So LCM of denominator is 6, 2 and 3. So multiply numerator and denominator to the 6 here, or make it as 2, 6. So by which number you will get a denominator as 6? By 3. So by 3 only you have to multiply, minus 3 by 6. Then for the 2 by 3, so I need for the 6 means 2 by 2. Okay, 2 2s are 4, 3 2s are 6. Now you can get C. See, minus 3 to 4. So minus 3 by 6, 4 by 6. Keep it in mind. This is a positive, this is a negative. So why we are taken minus 2 before, minus 2 by 6, minus 1 by 6 and 0 by 6, 1 by 6, 2 by 6, 3 by 6. Is it not? So how many are there? 1, 2, 3, 4, 5, 6. 6 are there. Okay, so 5 rational numbers between any numbers you may take. Okay, so these are the rational numbers. Then go for the second. Write 4 more rational numbers in each of the following pattern. See, pattern is there here means we have to observe the numerators and denominators separately. Numerator by which 3 2s are 6, 3 3s are 6, sorry 3 3s are 9. So are they the table of 3 or not? Isn't it? So if this is a case, what we can do, we can multiply the, it is by 2, it is by 3, it is by 4, then by 5, 3 5s are 15. Okay, it is the table of 5, then 25, then again 3 5s are, so by 6 are minus 18 because all are minus, again 30, like that. Okay, you must continue it. Then 7s are 21 minus 35, again minus 8s are 24 by 40, like that. So if next one, see, minus 1 2 3 are there, minus 4, minus 5, minus 6, minus 7. So denominator afterwards again. These are the table of 4 or multiples of 4. 4 2s are 8, 4 3s are 12, 4 4s are 16, and 20, 24, 20, 30, 28, like this. Okay, I think you hope you understand. We can check. So I'll go for the next question. Third one, Q4 rational numbers equivalent. So rational numbers, you know, same as it is as fractions. So this I have showed in the example. So directly multiply the numbers and find the equivalent rational numbers. Then draw the number line and represent the following rational numbers on it. So this also I have showed it. So 4 denominator is there, means 4 equal parts we have to do. Positive is there, means go for the 0 from the left to right. Negative means go for the right to left here. So this I have shown. Okay, remaining you must do. So then go for the fifth question. The points P, Q, R, S, T, U, A and B on a number line are such that TR is equal to RS, RS is equal to SU, SU is equal to SU, and AP is equal to PQ is equal to QB. Name the rational numbers represented by PQRS. So we have to select. See here, between 0 to, how we have to select? Between 0 to 2, TR is equal to RS. RS is equal to SU, means the distances are same, means so minus 2 to minus 1, total number of parts are 3. See, 1 2 3 parts, so total number of parts are 3. Then what is T? Then T is a minus 1. Okay, minus 1, but 3 parts are there, means I can multiply by 3 by 3, so minus 3 by 3 I can denote. Then what is the R? Is minus 1 by 3. Sorry, not minus 1 by 3. I'll make it as a 1 2 3 parts. So at that time what it becomes? First one, second one, third one, fourth one. So it is a 4 by T here, 4 by 3. Okay, I hope you understand or not. See here, they made all our total number of parts are 3. Okay, once again I am explaining. So you have to make it as all are part 3. Okay, I'll make it. Okay, 2 lines means 3 parts. So now T, count it. Minus 1 2 3. So it is minus 3 by 3. T1. Then R1 is 1 2 3 4. Fourth one it is. So minus 4 by 3. Then S1. S1 is 1 2 3 4 5. So minus 5 by 3. Okay. Minus 5 by 3. Then U1 is 1 2 3 4 5 6th one it is. So minus 6 by 3. Okay, what they said, PQRS means R and S we got. Now P and Q. So P and Q means count it. 1 2 1 2. So P, I need P means A also we can write. First P I'll take 1 2 3 4 5 6 7. So minus 7 by 3. This is how. Okay, minus 7 by 3. Then Q, 1 2 3 4 5 6 7 8. So this is the 8th one. So minus 8 by 3. Then for A, 1 2 3 4 5 6. So it is a minus, so not minus, these all are plus. No, this side it is, sorry, plus plus 6 by 3. Then for B, 1 2 3 4 5 6 7 8 9, so it is a 9 by 3. You may simplify here as. Okay, I hope you understand how we can locate. Now, which of the following pairs represented the same rational number? See, same rational numbers are there or not, we have to check by taking the LCM of the denominator and make it as equivalent fractions. Then we can write, or first, or take the lowest form of those. Both way. First, as if it is, you may check by the lowest form. See, minus 7 1s are 3s are. So here minus 1 by 3, 3 by 9 is there. Okay, 3 1s are 3 3s are. So 1 by 3. Are they equal? No, because it is a negative, it is a positive. So these are the not equal. We cannot write. Okay, then go for the 16 minus 16 by 20. So here also by simplification, if it is possible, you can bring it as a lowest form. So these are the 16 and 20 are the factors of multiples of 4. 4 4s are 4 5s are. So minus 4 by 5 it comes. Then 20 5 5 4s are 5 5s are. Okay, see here, this is 4 by minus 5 comes. See, always in the denominator we should not keep the minus. What we can do is, instead of keeping the minus denominator, numerator also we can keep. See, now minus 4 by 5 minus 4 by 5 are equal. Okay, this is how we can do it. Okay, then go for the next question. Rewrite the following rational numbers in the simplest form. See, in the simplest form, you know that by cancellation of the common factor in the numerator and denominator, in the fraction you have studied, no, in the same way. So 8 and 6 is a common table in a 2, 2 3s are 2 4s are. So minus 4 by 3. In the same way, 5 5s are 5 9s are. So 5 by 9. Like that. Okay, it is also same. I hope you understand. Then find the fill in the boxes with the correct symbol. So fill in the blank boxes with the correct symbol out of less than, greater than, and equal. So see, if you want to find these all are equal or not, or greater or not, lesser or not, we can make it as a same denominator. Okay, same denominator means take the LCM of the denominator and make it as a same. So 7 3s are 21. So 21, instead of checking the 21, first we have to check whether both are negative or positive. If one is positive, one is negative, means since 2 by 3 is a positive, 2 by 3 is a positive, always it is greater. So less than we have to write. In the same way, minus 4 by 5 minus 5 by 7. So here we have to multiply, make it as a same. When it becomes 5 7s are, so 7 by 7 you have to multiply 5 by 5. So what it becomes, 4 7s are minus 28 by 35, and this is minus 25 by 35. See now, minus 25 is greater or minus 28 is greater. So minus 25 is greater than number. So at that time it is also less than only we have to write. Then here both are negative only here. So better you have to simplify better by 8s. So 2 8s, 2 7s. See here. Now minus 7 by 8, this is also minus 7 by 8, because in the denominator we cannot keep the negative sign, it is not a proper way. So that's why we have to transfer to the numerator, that one. That's why, so these are equal, we can write. Then this one, see, denominator are different, we cannot cancel, both are negative only, make it as a same denominator by taking the LCM. So by which number you want to multiply? by 4 by 4 by 5 by 5. Okay, so what it becomes? Minus 40 by 20 and minus 35 by 20. So which is greater here? Minus 35 is greater, because minus is the integer, the lesser numeral is the greater value, so it is a greater. Then you know this in the integer, keep it in mind. So remaining is yavat. So these are equal, and 0 is a positive, that's why it is greater. Okay, I hope you understand. Then ninth one, which is greater in the each of the following. Same, just now we have done in the processes, no? Same, take the LCM of the denominator, make it as a denominator same, then you have to compare the numerators in the fractions as you did. Now write the following rational numbers in ascending order. So it is ascending means, so all are in the same denominator. Ascending means from smaller to lesser. Smaller is means minus 3 only, so it is already in the ascending order only. Why? Because compared to minus 3, minus 2 is bigger. Minus 2 compared to minus 2, minus 1 is bigger. So negative value, negative integers are having a smaller numeral has a bigger value. So here not are in the same denominator, make it as a same denominator by multiplying by 3 by 3. Here also by 3 by 3. So what it becomes? 3 by 3 minus 2 by 9 and 3 by 9. So it becomes 3 by 9 minus 2 by 9, then minus 12 by 9. So if it is the case, first ascending means lesser, smaller number will come, so that is minus 12 by 9, then minus 2 by 9, then a 3 by 9. So this is how you have to check. Now here numerators are same means denominator we have to check, which is a lesser denominator, no, that will be greater. But here if these are the negative numbers, same as it is, lesser only, the smaller value. Now I think we can go for the next exercise here. So exercise, these are addition and subtraction basis. Directly I am going, because you know the method of fractions, addition and subtraction. If the fractions are there means, so when the denominators are different, directly we can add the numerators. If the denominators are not same, we have to make it as a same denominator. When it is possible, by taking the LCM of denominator, then apply the integer rule for the addition numerators or subtraction numerators. Okay, so I'll go for the first one. 5 by 4 minus 11 by 4. So denominators are same means we have to apply the numerators. So plus into minus, you know the integer rule. See here, addition and subtraction means we have to apply the integer addition and together fractions. There is no extra rule here. There is no extra rule. Only integers and fractions we can processes we can apply to add and subtract. So here plus into minus, plus into minus, minus. So 5 minus 11 minus 6. So denominator as it is. So simplification, 2 3s are 2 2s are. So minus 3 by 2 here. Then go for this one, second one. Denominators are not same, so take the LCM. 3 and 5, LCM of 3 and 5 is 15. So denominator make it as a 15. When it is possible, by multiplying by 5, by multiplying by 3. So here we did by 5 by 3 directly. Then 5 5s are 25. Then 3 3s are 9. So 15 comes directly. What we can do, 15, same denominators we have done. We have done the same denominator, so directly add 25 plus 9, as a 34. So we can convert it as a mixed fraction also. In the same way, third one, minus 9 by 10 plus 22 by 15. So here also the denominators are not same. Better take the LCM of the denominators. So how it is, you know the method. So 5 2s are 5 3s are. So multiply all. 5 2s are 10, 10 3s are 30. So 30 is the LCM, means make it a 30. When it becomes 33, so multiplying by 3 by 3. And here when it is 32, so into 2. So that's why it is minus 9 by 9 into 3, 22 into 2. So here then 9 3s are 27, 22 into 4 to 44. So now the denominator is same, but it is a 20 minus 27. You know the addition rule in the integers. So when it is possible, minus 27, 1 is a minus, 1 is a plus, what you have to do, subtract it and keep a bigger number sign. 44 minus 27 is 17. Bigger numeral is 44, that sign is plus, that's why it is plus. Okay, I hope you understand. So remaining you must do. Then there is a subtraction here. There is a subtraction, same thing here. Here same, but only subtraction taken place. Here also the denominators are not same. What we can do, make it as the denominator same by taking the LCM of the denominators and subtract it. Okay, it is your work. Then find the product, same thing. Numerator to numerator you have to multiply, denominator to denominator you have to multiply. See, 9 7s are 63 minus, because you know the multiplication rule of integers. 9 7s are 63, plus into minus minus, so minus 63 by 8. So that we can convert it as a mixed fraction with a negative, because negative is a numerator. Then here also minus 9 I can write as a denominator 1. So 9 3s are 27, 10 1s are 10. So this is also having the same rule of fractions. So that's why I am going hurriedly, because the all are application of a fractions only and integer. Then find the value of, here division is there, so same thing. So minus 4 is there, means minus 4 keep as it is, or you can write a minus 4 by 1 and take the reciprocal of second one to convert the multiplication. So 2 by 3 reciprocal is 3 by 2. Then multiply numerator to numerator, denominator to denominator. Minus 4 into 3 is minus 12, 1 into 2 is 2. So you can cancel 2 1s are 2 6 are, so minus 6 by 1 we can write as a minus 6, isn't it? So in the same way, this third one or a second one, minus 3 by 5 divided by 2. So minus 3 by 5 as it is only you have to write. So to convert the division to multiplication, we have to take the LCM reciprocal of 2. 2 we can write as a 1, means reciprocal is 1 by 2. So multiply numerator to numerator, denominator to denominator, minus 3 by 10. That's all. So this is how you have to do the addition and subtraction, multiplication and division here. So this is all about the rational numbers, how to add, how to subtract, how to multiply and how to divide. See, don't forget here the rules of integers and fractions together you have to apply in the rational number. So I hope you understand. Thank you one and all.